My name's Alex Ollman. I'm the product manager, or one of the product managers on the HPE Ezmeral software suite. And firstly, thank you very much to not only the AI data infrastructure field day team, but all of you here as delegates for warmly welcoming me to the stage. And today, I think, having looked at a few of the other sessions, even just walking in, I think this might be a little bit different. And so I'm very excited to get your active and respective feedback as the session goes on. But what I want to first cover is something that, as a result of sort of my background and my coming into the enterprise infrastructure industry, especially now working for a vendor, and the conversations we have around, obviously, a lot of our existing clientele are going to be people who want to buy boxes. Maybe they'll put some of those boxes together, put some software on top with our respective software partners, and build together a solution. More often than not, that's where the focus usually tends to stop. The people who are going to be using that infrastructure are abstracted from sometimes that decision making. And I think we've seen a lot more, particularly in not just the software as a service, but the abstraction of infrastructure through not just public cloud vendors, but hybrid cloud vendors like HPE. We've begun to see those people start to be integrated into the conversation. None more so than recently, where we now have people along the machine learning operations workflow, those that are going to be bringing generative AI applications to the foreground, not just being consulted on the infrastructure conversation, but demanding that infrastructure. This is a need now, and it's a rapid need. And what I wanted to do is actually break down exactly what that need is, why it exists, and why rapidly trying to get to the end result is sometimes going to be not always the best solution. And so I want to start here in terms of and to give a little background to me. So I graduated with a Bachelor of Engineering, specifically in robotics. And robotics is more often than not the application of not just machine learning, but control algorithms, sort of watered down machine learning algorithms, if you will. And our entire point of that particular domain, particularly for robotics, is to get them to do a physical actuation. Based on a command, can you do this thing? Can you interpret space, your senses, your information? And can you perform an action through actuation that ends up in a result that I want, as a human I want? Now, the more automated that can be, the better. I don't want to have to direct a little robot through this hotel hall. If it could do it itself, go all the way up to my floor and bring me a beverage, that would be pretty handy. Great little service the Hilton could offer. I'm giving that one away for free.
Yeah, it's named Toady.
Toby, I did see Toby outside.
Yes.
Hopefully Toby extends to room service by 2025. And so the reason I said this, I had an understanding of what applied machine learning was. And coming into the world, particularly around infrastructure and enterprise, more often than not, that abstraction of people who use that enterprise infrastructure and the people making the purchases were often, just to start off, mixing up the nomenclature. And so I wanted to clarify contextually what we are going to be talking about today when I say generative AI or artificial intelligence. Because there's a lot of synonymous nature with the way in which people use this language. Artificial intelligence describes the behaviors and techniques that are used to mimic human behavior or decision making. Those techniques may include machine learning. However, it should be obvious to you now, those terms are not synonymous. More often than not, they are. They are combined together, usually with a slash in between them, sometimes parentheses, if people are feeling audacious enough. And a subset of machine learning, that is to say, taking a data set, things that we have observed in the past, and wanting to predict, abstract from that data for any given use case, we would usually get a machine to go through that data, perform pattern recognition, and the model that it would build that represents its learning is called a neural network. And in 2017, Google kind of changed the game a little bit. they realized that instead of having to take a lot of input and have it try to work through and build a lot of output, they could train a ludicrously large model to be able to generate an answer in real time. Rather than having direct input, output, what if I could just make the next small prediction and perform that with it through iteration? They introduced a technique called the transformer model. Now, the transformer model you may have certainly heard about or heard of, because it is the T in generative to generate the next small portion of, say, a sentence. The quick brown fox jumped over the lazy dog. That's generating the next token and doing so iteratively. And it's able to predict what that is and generate that next word because it has been pre-trained on an enormously large data set, a generative pre-trained transformer. And when we fine-tune that generative pre-trained transformer to be able to not have inputs and outputs that are more human, conversational, a chat, you might say. Suddenly we have a model that we can release to the world, ChatGPT. And that's what happened in 2022, where large language models, a subset of transformers, came to the foray. And I wanted to provide that context because, particularly in this space, it is usually not the care nor need to care for those working in infrastructure to be able to make this abstraction. As far as I am concerned, large language models are artificial intelligence. But the way in which the underlying infrastructure is going to be scoped, designed, deployed, and served, particularly to the people working with large language models, is very different to those working with neural networks and other machine learning techniques. So that's why I wanted to provide that foreground there. And before I do continue, does anybody here or online have any questions?
So we've had an interesting discussion earlier that was kind of aligned with this. Mm-hmm. And in particular, he was liking the concept about talking about personas. Mm. And so when you go down this stack here, or the bubbles or whatever they are, where do you see the different personas playing in here? Especially as I think, I kind of know where you're going to be going with the offering here, but yeah. That
is such a wonderful segue into actually the next talk, literally straight out of the park. Because in this next talk I would love to actually go through with you and describe the personas that usually have to work with getting the data to neural networks for predictive AI, for large data sets to build and vectorizing them for generative AI applications. And that they would usually more often be data engineers, data scientists, machine learning engineers, AI engineers, application developers. Those personas are going to find their way not just up and down in terms of this domain, as it were, but also up and down the infrastructure stack. And it's for that reason that I'll probably, if I may, hold off on that question, because everything we're about to allude to in that next conversation is actually going to be a hands-on demonstration of being able to empower those personas with underlying infrastructure.
Right.
Cool. And I just want to also touch on those applications in terms of the differences here. Because the world as it currently stands, when we talk about and we consider AI as a nomenclature, we're talking about prediction models. Being able to predict house prices over the next 2 quarters, stock prices. We want to talk about temporal uses. That is to say, being able to perform a time series estimation. Things that are happening in real time. That's my domain in robotics. I'm just caring about the next time step, not about the next quarter for prediction. I talk about imputation, missing entries in data sets. Can we extrapolate on the data that we already have to add missing entries? Or maybe in the case of, particularly polls, I know that's very relevant in this country at the moment, for no particular reason, but taking a poll from a small sample size and being able to accurately extrapolate that across a larger population in absence of a large data set. Lastly, detection. We've all certainly seen object detection models, things that are being used particularly in medical purposes as well. Those are examples of where a smaller neural network model is going to get better and better, big asterisks on that of course, but better and better as more data is fed into it. But the size of the model is going to be very small because more often than not, it's for a specific use case. These are specific models and specific techniques. every single time you open Spotify on your phone, to be able to generate the content in real time, number of data pipelines are triggered to give input to hundreds of models that in real time are able to give you the best curated experience on those applications. Whereas for generative models, they are very large and very computationally heavy. Why? Because they have been trained on a large general set of data, and they are general by design. You will notice that the smaller and more concentrated the data set, of course, the smaller the model will need to be to get the same level of accuracy that a larger model would need to have for general application. And I hope that at least for everybody listening here, that in terms of the underlying infrastructure that would be required to run a general model versus a specific model, these are the sort of decisions that those working with infrastructure need to understand, and therefore need to consult with those people and the models that they will be creating, those personas, as you described, so that they have that understanding. And those applications may be code generation. It'd be really nice if I had someone who knew, I don't know, every programming language there was. Document creation, to be able to save time based off of documents that my company and organization have already created. Image generation, conversation through chat agents that we've already seen previously. These are applications of those models. And when I say that there is a difference between AI and AI, this is what I mean. The underlying data that is required to create these use cases and the underlying infrastructure looks very, very different. So this is what everybody wants right now. It seems to be the flavor of the month's last 2 years and potentially the next 5 if the stock market is telling us anything. And so what does this actually look like? What does everyone want to get to? I want my code generator tomorrow so I can get my people being 70, 80% faster in terms of time to deployment of code projects. I want my people not having to grab 8, 9 different documents from OneDrive and be able to work out a nice report. I want to be able to do that automatically and save them time. I want to be able to generate images that are relevant to my organization so I can put it in the next newsletter so I don't have to think about what stock photo I'm going to get without licensing agreements and all that jazz. And conversationally, I have a lot of organizational data that it would be so nice just to ask the question and find the right answer to. What does that look like in practice? It looks like a deployed application. Everybody wants to get here. This is the sex appeal of modern AI. It is the chat GPT. I want that for me and my very specific use case. That is why Pandora's box was open in November of 2022. Not because the technology was made available. In fact, the underlying model behind ChatGPT was publicly available to all of us since 2020. It's because we, for the first time, could understand and abstract what we were seeing in front of us, question and answer, into a world of possibilities within our own domain and expertise. We want to get here. And this is a conversation that almost every customer, every partner, every single person we have spoken about AI more broadly wants to get to yesterday. And there are a number of organizations, number of software vendors in particular, that will leverage that sort of market demand. You can have this now. And what I want to actually walk through here is what is required in order to get to a deployed application. Well, first, if it's going to be something that's relevant to my organization, then I need to give it context to my organization. I need to be able to give it specific data. That requires me to go and already have multiple data sources, structured SQL databases that tell me historical data for as long as that database has existed. Maybe it's relevant PDFs and documentation stored across multiple different files, object stores in multiple different locations. Just getting this data to this application via somebody making it is not trivial. Anybody who has worked in database administration and even just providing authentication keys for someone to access it will be able to tell you that. Once you have gathered the data though, and you have access to it, you then need to prepare it. A large table with millions of rows and hundreds of columns is no good for a specific application. I need to be able to query that database to then get a data set. That also works for large file and object stores with thousands of documents. Not all of them are going to be relevant to my specific chatbot application, shall we say.
So, hey, Brian.
Hey, Brian.
So I have a question about structured versus unstructured data, right?
Yeah.
So first differentiation there, structured data coming out of a database, rows, common format, unstructured data, PDFs, Word documents, PowerPoints sitting on your... So just to set the context of what you're talking about here, are you talking about structured or unstructured data? And probably there's a further question there with, of course, structured, unstructured, and unstructured, unstructured, but I'll leave that until...
You are more than welcome to jump into that question now if you like, just checking on time that we are able to do so. But when I say that, yes, I mean unstructured and structured data. So when I say unstructured data sets, I mean usually they're having files that are stored as objects. Maybe that can simply be a PDF that has just been broken down and stored at an object store. I mean, it could just be a little bit of JSON stored somewhere in a large data lake. It could be anything like that. Or it could be something like, or I should say retrieved through a large data lake, I should say, to clarify. Or I'm making a query to a structured database in whatever language that database happens to speak. And the data that I retrieve from any of those data sources, I then need to do something with in order for a large language model or an equivalent generative model to be able to understand and do something with.
Okay.
Did you want to follow up with that question on?
I'll wait. I'll let you.
Oh, yeah. Sounds good. And so once I have prepared that data, I've refined that data set, now I need to select the data that I have, the data sets for my given use case. So I've prepared it, it's all ready to go. Now I need to select it for a given use case. And only then would I need to either choose an off-the-shelf model. Maybe that model doesn't exist for my given use case and I need to go out and build it. I then need that expertise. I then need a base model to work off of, maybe want to fine-tune an existing model. And that underlying infrastructure, both in software and in hardware, would be required. Why only then, regardless of whether or not I've grabbed one off the shelf, or I've trained, fine-tuned on the data set that I pulled, can I validate it for a given use case? Great. Only then have I gone through that validation step, by the way. And in larger organizations, there'll be anything associated from making sure the application is correct, beta and user testing, legal. Only then do I now get to reap the rewards of the large language model application. And this was the context I wanted to provide everybody here. Getting to this point is non-trivial. And it's important that these steps are not only understood, but respected. And that getting here can certainly be abstracted and made easy. And it will continue to be easy as vendors, not just like HPE, but vendors begin to abstract these steps to make it as easy as possible to get there. And what does that abstraction look like, at least from these steps? Well, it's automating the data preparation. It's being able to make data connected to multiple sources easy. It's being able to create data pipelines such that for any given use case, I can then have that I can actually maybe even automatically spin up a data pipeline that will trigger based on either event or a time or a given timestamp, once a week, once a quarter. Have that all automated for me. Suddenly, that's no longer a requirement for me. It could be automated model orchestration. Take a model from a repository based off of a natural language use case, spin it up for me. Don't need to worry about it. I trust that it's the right model. Maybe even, we don't even have to do that at all. Maybe I can have all of that abstracted for me by some prepackaged large language model application that I can just pass some data. These abstractions are only as good as the understanding of the people implementing them. And that goes all the way up and down that stack of personas, not just to those who would be doing that implementation with that expertise, particularly in data engineering and data science, but all the way down into the infrastructure layers. And this is why. Because without an appreciation for the data that is going to, and making sure that is curated and all the steps associated with preparing data for it going in, the output from generative models is sometimes going to be wayward. Sometimes is okay, but not if you're a major multinational, not if you're a bank, not if you're an airline, not if you're that person, an organization who is dealing with customers each and every day. You are a major airline that had to console a grieving individual because it gave a misrepresentation of the policy that it was fed as contextual data, wasn't even trained on it. This was a quick implementation, if you notice by the date there. It is not putting any guardrails or having any appreciation for that building, training, or validation, in this case, of the implementation of a model. Suddenly, I could call this particular car dealership up, and it would actually encourage me, if I prompted it correctly, to go buy the car of a competitor. It could also tell me how to make a really nice egg salad sandwich for lunch. And there was a particular use case where sometimes the generation of a large language model without the underlying data and the correct implementation steps gives us very unpredictable results. This is not something we can afford in the enterprise. It is not something we can afford, particularly on infrastructure, that anybody here will know, even just going out and getting quotes for, is quite expensive. So, how do we do this? Well, that abstraction is really important. We still need to accelerate the time to value for any AI investment, predictive or generative. But that comes with that appreciation. Now, my first 3D printer was just shy of 10 years ago. And it was a Robo 3D, which actually started on Kickstarter. Tried to be one of the very first commercial 3D printers available that I could have in the home. Now, this particular printer, 3/4 of the time, wouldn't even start the print properly, wouldn't adhere to the bed. And even when it did, it sometimes began to drift off askew even just after the first few layers. It all came down to how I leveled the bed, how I made sure the right temperature of the nozzle and the bed were in place based off of the ambient environment in the room, that the enclosure didn't abstract on the cabling, and most and more importantly, being able to go to sleep next to my loving partner, who after the third time of getting up to check on the printer for an overnight print, looked at me and said, "It's either me or the printer." Fast forward to today. This is a Bamboo X1 Carbon. I bought the smaller little brother of this, but I put this up there because it is sort of a better representation of this analogy. I bought this printer knowing that I could buy a really cheap $200 printer, $100 printer off of Amazon, that I knew I had the skills and expertise, given far too much pain and torturing myself with my previous printer experience, to go through it and manage that again, save a bit of money. I decided to spend a little bit more. Not because I can plug it in, to have it set up in 10 minutes, and I have not had to level a bed once. I did not have to take the 2 filament rolls of multiple colors and manually splice them together with a heat dryer to get different colored prints. I bought it and it was ready to go out of the box. These steps of complexity were not only abstracted, but I had the appreciation for that abstraction. I realized that without going through this experience, people buying a Bamboo Lab printer today would not be able to appreciate any of the underlying steps required to perform 3D printing. More importantly than that, if that goes wrong, they're going to call Bamboo support. There is not going to be an appreciation for the underlying steps as to why something, even if it doesn't go wrong, how can I even improve on the experience I already have? And that's where I wanted to get to with these 7 steps here and what abstraction looks like for generative AI applications. Because the underlying infrastructure looks like the following. It looks like having GPU accelerated compute, because I alluded to earlier, these models are not now in the tens or the hundreds of megabytes. They're in the tens of gigabytes. NVIDIA's biggest and beefiest GPU available to us today, put the little asterisk there, has 80 gigabytes of GPU memory. And as I'm about to get to a little bit later, that's only enough to fit 1/4 of ChatGPT as a model. And so we need that GPU accelerated compute. We also need to have the ability to take that model from local storage, if it's going to be in our own house, and put it over into that GPU's memory. That requires quick access storage and it requires incredibly fast networking. We then need to have access to that infrastructure by abstracting it, of course. It's what we in the infrastructure world have been doing for a long time, abstracting technical complexity. And we do so through, we can either virtualize software and resource provisioning for individual personas so that they can perform each one of those 7 steps of machine learning operations you see above. And only then can we actually have our software application, a software application layer, be able to manage the applications on top that are either going to be internally facing in terms of training and working with data and all the tool sets we need to actually get to the end user application. And even then, we still have to deploy that and inference the models below. And abstracting that away is something that we have been really strongly working towards, but not because we want to take away any of the pain. Of course we want to do that. Who doesn't? But because we want to do so from a platform perspective, such that the infrastructure is still available to those who know how to work with infrastructure best, but they can deliver now the tools, the resources, and the underlying compute and storage networking infrastructure to people who work in these domains, those very personas you alluded to earlier, to be able to get right to work. And that's something we're going to go through in the next talk. So